Okay, so we talked a little bit about homeostasis in the PowerPoint, and we're going to get much more into it when we get to the endocrine system and we really talk about feedback. But one thing I just want to point out before we get there is a graph that looks like this, or a chart that looks like this. You'll see that there's a line that goes up and down, and you'll see that there's a line that's labeled set point. The set point is your homeostasis. It's balanced. See, that line is straight, it's flat, it's not wavering. That is homeostasis. That being of everything is working fine, everything is healthy, so it's just kind of a straight line. But over the course of the day, things happen, and then you get out of homeostasis. So you'll notice here it says a disturbance, and there's a change detected, and you're increasing, you're going over your set point, whatever it happens to be. Then effector reverses the change, and it's going down. And so you're trying to look right here, get back to that set point, that homeostatic level of being balanced. But unfortunately, you pretty much will never get there. So you overshoot and now you go below your set point. Once again, though, you'll see that it's going to affect change. It's going to increase you. It's going to try to get you back up to that set point. There's a few different types of graphs. So you see this one. Here, this one shows you the exact same thing with just a little bit more description on it. So you first see that you have your deviation from set point. You have then your corrective action where you're trying to return back to the set point. But once more, you notice that unfortunately, you don't get straight to the set point. You go below it. So we take some sort of other corrective action and we try to go back up towards it. But unfortunately, yet again, you've overshot it. And it's just constantly back and forth, up and down this way during the course of the day. Here is one that's actually a little bit more descriptive. As an example, you see it says body temperature. So we know humans, you like to be about 98.6 degrees, give or take, depending on the person. That's approximately 37 degrees Celsius. That would be your set point. So this line here represents 37 degrees Celsius. But something happens, it's hot outside, it's hot in your room, you exercised. Your body is going to detect that your temperature is too hot because it increased because of the heat around you or the heat of what your body is doing. So we're going to try to decrease your temperature. Your brain is going to cause a bunch of things to happen. I say things, I'm not getting into them, we'll get into them later. In your body, that's going to cause your temperature to decrease, trying to get back down to that 98.6 or 37 degrees Celsius, but it doesn't work. So now you go below that, so now you're too cold. So you put on a sweater or you start shivering, you start shaking. Again, something to try to bring you back up to that set point. And it's just going to up and down all day long. Now, sometimes the line gets closer, that deviation mark gets closer. Sometimes your deviation mark is closer to the set point. Sometimes it may get even further away from the set point. But no matter what, it's always trying to get back there to that set point. Again, that set point is your homeostasis. It's that straight line here that means everything is perfect, and that's always where you want to be, and that's always where your body is trying to get it to be.